Hi everyone, we are from Group 4 and today we would like to share with you about technique of differentiation. I'm Muhammad Rafiq, the group leader, and here are my group member.
My name is Samson Wong.
My name is Boyman Bohan.
Question 1. The definition of differentiation. Differentiation is actually the process of finding the derivative of a function. The derivative measures how a function changes as its input change. They represents the slope of a function at any given point. There are 5 different techniques of differentiation. First of all, constant rule. Constant rule is always used when differentiating a function where the term being differentiated is a constant. So, the derivative of a constant is always 0. Secondly, the power rule. The power rule is usually find the derivative of function where a variable is raised to a power. As example, a constant exponent. And the formula for it is fx equal to x of the power of n, and f prime x will become nx n minus 1 at the power of it. Thirdly, quotient rule. Quotient rule is usually used to find the derivative of a function that is the result of one function divided by another function. The formula for it is d over dx times by u over v. Then we need to find for the v prime and u prime, which becomes vu prime minus u v prime over v squared. Fourth one, product rule. Product rule in calculus is usually used when we need to find the derivative of a function that is the product of two other functions. The formula for it is d over dx times u times v. Then it will become u prime v plus u v prime. Last but not least, the chain rule. The chain rule is usually used when differentiating composite functions which are functions within another function. And the formula for it is dy over dx f prime gx times with g prime x. Question 2. We need to find the dy dx for the following function. For question 2a, y equal to 4x squared cos 5x minus 2. From the function, we can see there are two separate functions, and the 4x squared cos is a derivative one. So in this case, we need to use product rule. So firstly, we need to let u become u prime. So we need to put this power of the power in front of the constant and times it. So 4x squared will become 8x. Then the power will be minus 1. Then it will become 1. For v, we also need to find the v prime of it. So cos 5x minus 2, then it will become minus sin 5x minus 2 times 5. Then for the next step, we will let it be dy dx. So u prime v plus u v prime. This is the formula for product rule. So we're gonna substitute the answer that we have counted for u prime and v prime earlier. So based on the formula, we're gonna just substitute it in it. So at x times cos 5x minus 2 plus 4x squared times minus sin 5x minus 2 times 5. Then the answer will become 8x cos 5x minus 2 minus 20x squared sin 5x minus 2. Question 2b. Y equal to 3x plus 1 over sin 2x. From the function, we can see there is a denominator and a numerator, which we can know that we will use quotient rule for this function. So we need to let dy dx equal to vu prime minus uv prime over v squared. Then we're gonna let u equals the numerator, which is 3x plus 1. So the v prime will be 3. Then we will let v equals the denominator, which is sin 2x. So v equal to sin 2x, then the v prime will be 2 cos 2x. Then we will let dy over dx equals to vu prime minus uv prime over v squared, as it is the formula for quotient rule. So since we have counted the value of u prime and v prime, we can just substitute in the formula given. So dy over dx equal to sin 2x times 3 minus 3x plus 1 times 2 cos 2x over sin 2x. Then for the numerator part, we can factorize out the one that we need to. So it will become 3 sin 2x minus 2 3x plus 1 cos 2x. There we need to let the denominator remain the same, so it still be sin power of 2x. Then the next step will be the final answer of it. The final answer of it is 3 sin 2x minus 6x plus 2 cos 2x over sin square 2x.
For question 3, first, we need to differentiate both sides with respect to x. Let's start with the left hand side. First term, the derivative of y ln 2x, we use product rule. They give us dy over dx times ln 2x plus y over x. Then the derivative of e to the power of 5x plus 3, we using the chain rule, we get minus 5e to the power of 5x plus 3. So the full left hand side become dy over dx times ln 2x plus y over x minus 5e to the power of 5x plus 3. Now we do the right hand side. The derivative of tangent of 6y, we apply the chain rule against. It will become 6 secant square of 6y dy dx. Now we say both side is equal. Dy dx ln 2x plus y over x minus 5e to the power of 5x plus 3 equals 6 secant square of 6y times dy dx. Now we will move all dy dx term to one side. Dy dx times ln 2x minus 6 secant square of 6y times dy dx equal 5e to the power of 5x plus 3 minus y over x. Now we factor up dy dx. Dy dx times ln 2x minus 6 secant square of 6y equal 5e to the power of 5x plus 3 minus y over x. Finally, we solve for dy dx. Dy dx equal 5e to the power of 5x plus 3 minus y over x all over ln 2x minus 6 secant square of 6y.
I will now explain question 4, which is about estimating a value using linear approximation. Here is the question. Estimate the value of cube root of 63.98 minus 2 divided by square root of 63.98 using linear approximation. Now let's solve it step by step. Step 1. Write the function. We define f of x equal cube root of x minus 2 divided by square root of x. In mathematical form, that is f of x equal to x to the power of 1 over 3 minus 2 times x to the power of negative 1 over 2. Step 2. Choose a value of x that is easy to calculate. We are estimating the value of fx equals 63.98, so we choose a nearby number that is easy to work with, which is x0 equals 64. Step 3. Find the change in x. Delta x equal x minus x0, so 63.98 minus 64 equal negative 0.02. Step 4. Find the derivative of f of x. We differentiate the function of prime of x equal 1 over 3x to the power of 2 over 3 with a negative sign plus x to the power of negative 3 over 2. Step 5. Find f of x0. That means we find f of 64, cube root of 64 is 4 and square root of 64 is 8. So f of 64 is 4 minus 2 over 8, which equals 3.75. Now we substitute x equals 64, so f prime of 64 equal 1 over 3 times 64 to the power of negative 2 over 3 plus 64 to the power of negative 3 over 2. This gives us 0.0228. Step 6. Use the linear approximation formula. The formula is f of x is approximately equal to f of x0 plus f prime f of x0 times delta x. Now substitute the values. F of 63.98 is approximately 3.75 plus 0.0228 times negative 0.02. They give us around 3.7455. Finally, around the answer to 3 decimal place, 3.750. And that is the estimate value using linear approximation.
Overall, these techniques are essential for solving real problems in science, engineering, and everyday life, and mastering them is key in calculus.
That brings us to the end of my explanation for this topic. I hope it's helped you understand more about differentiation, its technique, and how we apply it to various problems, including implicit differentiation and linear approximation. Thank you so much for watching and following along. Now here are the references I used to complete this presentation. That's all. Thank you.